Well, I think I kind of alluded to this earlier. I mentioned that not all of the organisms in the soil are beneficial, but just to be sure that we have kind of a summary of that, I wanted to take just a minute to discuss non-beneficial effects of these microorganisms and in some cases macro in the soil. Of course, unfortunately, some of these organisms that live in the soil have parasitic forms. Well, I think I kind of alluded to this earlier. I mentioned that not all of the organisms in the soil are beneficial, but just to be sure that we have kind of a summary of that, I wanted to take just a minute to discuss non-beneficial effects of these microorganisms and in some cases macro in the soil. Of course, unfortunately, some of these organisms that live in the soil have parasitic forms. And during at least a part of their life cycle, they are living on our host plant, our crop plant, whatever that might be. And because of that, they produce detrimental effects, loss in yield, loss in aesthetic value. These are some of the effects that they can have. So certainly that would be considered a detrimental effect of microorganism activity. They're completing at least part of their life cycle in the soil, yet during other parts of their life cycle they are very active parasites either on the above or the below ground portions of the plant. Another detrimental effect that we have of organisms in the soil is that when in high numbers they can be extremely competitive with our crop plant for food. And by food here I mean the nutrients that are being taken out of the soil as inorganic ions by the higher plants, nitrogen as nitrate, sulfur as sulfate, and so on. If you have high levels of microorganism activity, those organisms are needing to be fed. They need to have nutrients, inorganic ions, for their growth and development, just like the crop that we're growing. So if we have a very high level of not highly altered or not highly decomposed organic material in a soil, the microorganisms are going to compete with the crop plant for elements that are typically low in quantity, like nitrogen, like phosphorus, like sulfur. And they can actually outcompete the crop for this and cause deficiencies of those nutrients to occur in whatever that crop might be that we're trying to produce. So that would, in those circumstances, would be considered a detrimental effect if you were the person trying to produce that crop, either for yield, aesthetic purposes, or whatever the case might be. And a third effect of, I should say a third detrimental effect of microorganisms existing in the soil as a part of this organic matter is that some of these, under certain situations, can actually take available forms of nutrients and convert them to unavailable forms. An example of that, if we have a waterlogged or anaerobic soil condition like I mentioned earlier, there is a type of bacteria that exists in the soil. It's called a denitrifying bacteria. It will take nitrate from the nitrate ion form, that's an NO3 with a 1 negative charge on it. It will take that nitrate ion and it will actually attack that nitrate ion, which is the primary form of nitrogen taken up by plants from the soil. It will attack it, it will break it down, it will convert it into a gas, and it will volatilize from the soil. Now, why does this organism do that? Well, it does it because it's looking at that nitrate ion as a source of oxygen. If there's not oxygen available as a free oxygen gas molecule in the soil, it's an anaerobic condition. Where is this organism going to obtain its oxygen? It's going to obtain it from an inorganic ion, and in this case that ion is nitrate. So it takes the nitrate ion, converts it into a form of nitrogen gas, uses the oxygen that was a part of that nitrate ion, and we get volatilization loss of nitrogen back into the air above the soil. Well, that's not going to cause any big concern about air quality because there's already 78% nitrogen gas in our atmosphere. But what it does do is it takes a plant-usable form of nitrogen and makes it into a non-plant usable form of nitrogen. So it's a direct loss of available nitrogen from the soil that could have been utilized by whatever that plant is that we have growing out there. Fortunately for us, this only happens in appreciable amount under waterlogged or low aeration environments in the soil. And for most purposes in this area, that's going to be a waterlogging situation that causes that denitrifying bacteria to kick in and take effect. So in summary then, detrimental effects include microorganisms competing with the plant for the nutrients in the soil, microorganisms causing diseases in plants, and thirdly, the one we just discussed, microorganisms taking plant-usable, available inorganic ions like nitrate, breaking them down into a gaseous form, they volatilize, and we lose those from the soil. Next, we're going to be discussing how we actually determine the organic matter content of the soil and what it means if we have a 2% versus a 3%, and what differences might we expect to see in soils as the organic matter content of that soil changes.